Hello and welcome students. My name is Dr. Vibha Shrivastava. Now I am going to start phase diagram of single component system. Now the next topic is application of phase rule in one component system. We are taking example of water. As water exists in three phases, solid, liquid and vapor. Even water exists in three phases, but all three phases have same chemical formula, that is H2O. So water system is one component system. Here we can see the phase diagram of water system or one component system. Let's have discussion about this. In one component system, the degrees of freedom seems to be related to the number of phases. And water exists in three possible phases, namely solid, liquid and vapor. Hence, there can be three forms of equilibrium. Equilibrium between solid liquid, equilibrium between liquid vapor, equilibrium between solid vapor. Each of above equilibrium involves two phases. The phase diagram for the water system is shown in figure. So, phase diagram consists of curves. There are three curves, OA, this is OA curve, OB, this is OB curve, and OC, this is OC curve. Areas A, O, B. There are three areas. First is A, O, B. Then A, O, C. Then B, O, C. B, O, C. These three areas in phase diagram. Now the triple point. The above three curves OA, OB and OC curves meet at the point O. It is known as triple point. Fourth curve is OB dash. This is known as metastable equilibrium. Now the description of curves. Curve OA. This is curve OA. It is vaporization curve. Here, this is OA curve, vaporization curve. It represents the equilibrium between water and vapor or water or gas. L, liquid phase in equilibrium with gas or vapor. At any point of the curve, following equilibrium exist. The degrees of freedom of the system is 1. That means univariant. On applying phase rule, F equals to C minus P plus 2. Component 1, phases 2 and 2 for temperature and pressure variables. So degree of freedom F equals to 1 or means system is in univariant. This equilibrium, that means this curve, line OA, will extend up to critical temperature. This is critical point or critical temperature. Temperature of this point is 347 degrees Celsius. Beyond the critical temperature, the equilibrium will disappear. Only water vapor will exist. What is critical temperature? It is the temperature of liquid vapor critical point. That is the temperature above which a gas cannot be liquefied by an increase of pressure. Now curve OB. This is curve OB. This curve is known as sublimation curve. This is sublimation curve of ice. It represents the equilibrium between ice and vapor. Solid phase and gaseous phase or vapor phase are in equilibrium. At any point of the curve, following equilibria will exist throughout this line, OB line. Now the degree of freedom for this system is univariant, or degree of freedom of the system is 1. F equals to C minus P plus 2, component 1, phases 2 plus 2 equals to degree of freedom equals to 1. This equilibrium, that means line OB, will extend up to absolute 0, 273 degrees Celsius temperature, where no vapor can present, only ice will exist. Now the third curve is curve OC. The curve OC is called melting point curve of ice. It represents the equilibrium between ice and water. Here in diagram we can see the equilibrium between solid and liquid phase on curve OC. The degree of freedom of the system is 1. That means univariant. On applying phase rule, the degree of freedom will be 1. The curve OC is slightly inclined towards pressure axis. This shows that melting point of ice decreases with increase of pressure. Now, triple point O. The three curves OA, OC and OB meet at a point O, where three phases, solid, liquid and vapor, are simultaneously at equilibrium. This point is called triple point. At this point, following equilibrium will exist: ice equilibrium with water and vapor. The degree of freedom of the system is 0. On applying phase rule, we will get degree of freedom 0. Here, temperature and pressure are 0.0098 degrees Celsius. Here we can see 0.0098 degrees Celsius and pressure 4.58 mm. Now, metastable equilibrium. The curve OB dash. Here we can see metastable equilibrium. OB dash is called vapor pressure curve of supercooled water or metastable equilibrium. Here, following equilibrium exists: supercooled water and vapor pressure. Sometimes water can be cooled below 0 degrees Celsius without the formation of ice. This water is called as supercooled water. Supercooled water is unstable and it can be converted into solid by seeding or by slight disturbance.